Today we will be talking about parent functions and their attributes. This is part 1 of a 2-part series. So the first thing on our agenda is to talk about, our agenda for today, our topic that we're going to address in this video is about linear, quadratics, absolute value, cubic, square root, and cube root parent functions. We're going to learn about the attributes of each of the parent functions, and when we're done, you should be able to identify the type of function based on given characteristics. So first we're going to start with a linear function. This is a linear parent function. So when we graph it, it's y equals x. So in the form of y equals mx plus b, my slope is 1, but since I don't have a y-intercept, it's a 0. So my parent function for a linear is going to go through the origin, and it's going forever in both directions. Okay? So as x approaches infinity, y approaches infinity. As x approaches negative infinity, y approaches negative infinity. Okay. So you can know that when x is positive, your y value is also positive. So if you look at the table, some of the characteristics on the table is the numbers are always going to be exactly the same. Okay, all the way across. Some of the attributes we have an x-intercept at 0, 0. That is also the y-intercept. This is where it crosses your x and y axis. Domain and range are super important, okay? Domain is going to go from negative infinity to infinity because it's going to continue forever in both directions. And the same as the range. As the x is going to negative infinity, your y value is also going down forever. So remember that we always write domain from left to right. We always write range from the bottom up. So the lowest value is negative infinity, and the highest value is positive infinity. The next parent function we're going to look at is a quadratic parent function. So the shape of a quadratic parent function is a parabola. That's the U shape that you see here. In behavior, as x approaches infinity, f of x also approaches infinity. Remember that f of x is your y value, so this graph is going up forever. Now when we look on the left side of the graph, as x approaches negative infinity, so as x is going towards the left, your y value is still going up forever. So these are both positive infinities. And if you look at the table, anytime you square the number, it's always going to turn into a positive. So again, parabola that's going up forever. Some of the attributes it has, x-intercept and y-intercept are at 0, 0. We also call this the vertex. So the vertex is the spot where it changes directions. So this graph was going down, 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 and when it got here, it changed directions and started going up. The axis of symmetry is what's going to cut your graph in half vertically. So the line here, this y-axis, another equation for it is x equals 0. And this is going to cut your graph in half. Domain and range. Well, on the domain, this x value is going to go to the left forever. It's going to continue. There is no stopping point. It's also going to continue to the right forever. So my domain is negative infinity to infinity. My range is my lowest y value. For the parent function, my lowest y value is 0. And notice that it has a bracket on it. The bracket tells me that it can be equal to 0. So this is 0 to infinity because it's going up forever. The next parent function we're going to talk about is the absolute value parent function. So it's going to have a lot of the same characteristics of the quadratic parent function. The difference here is instead of a U shape, this one's a V shape. But everything else is pretty much the same. For your end behavior, as x approaches infinity, the y is also going up forever. As x approaches negative infinity, the y value is going up forever. Okay, so that's where you get this end behavior here. Comparing the table from the last one, so we're not squaring anything. The numbers are going to be exactly the same, but when you take the absolute value of the negatives all turn into positives, okay? Because the absolute value is the distance from 0, so basically all the negatives turn to positives. So it should be a mirror image of each other, and again, this is a V shape. Some of the attributes it has is that it's going to cross the x and y axis right here at the origin, which are both at 0, 0. My vertex and my axis symmetry are the same as quadratic. So vertex is 0, 0, and this line right here, which is x equals 0, is what cuts the graph in half. My domain from the graph is how far to the left is this graph going to go? If you don't see an endpoint, that means it's going to go on forever. So the domain is going to be negative infinity, and my domain is going to go forever in the opposite direction, so my domain is negative infinity to infinity. My range, my lowest y value is 0, but my y value is going to go up forever, which means my range is from 0 to infinity. One of the things to note here is the transformation form. A is going to be in front of the absolute values. We're going to have an h, which is going to be inside the absolute value, and the k comes at the end. We have a cubic function. So this is the graph of a cubic, which is y equals x cubed, or f of x equals x cubed. The end behavior, as x is getting bigger, so as x approaches infinity, what's happening to the y value when I go this direction? The y value is also going up to infinity. Now when I look on the left side, as x approaches negative infinity, what's happening to my y value? The y value is going down to negative infinity forever. So I'm cubing the numbers, which means the signs are going to stay whatever the sign was. So negative 1 cubed is negative 1. Negative 2 cubed is negative 8. It's going to grow quickly. It's going to decrease quickly. So this graph is going to go down very, very quickly. Some of the attributes. This is going to cross your x and y axis at 0, 0. Okay. And the transformation form, we do have a in front of the parentheses, h is inside the parentheses, and k is at the end. Now the domain, if you don't see a stopping point, that means it's actually going to be going infinitely. So to the left right here, I don't see a stopping point. Even though it's going down forever, the x value is also decreasing. So my x value is negative infinity, and it's going to go forever to positive infinity. My range is easier to see on this one because it's going down forever, so it's going down to negative infinity, and it's going to go up to positive infinity. And remember, we use parentheses on infinities because we're never going to reach infinity. Now we have a square root function. This one looks a little bit different. Because we're taking the square root, we actually cannot take the square root of a negative number. So this graph does not come over here into the negative territory. When we take the square root, it's always a positive number. So the square root of 0 is 0, square root of 1 is 1, etc. So we take the square root. So the end behavior here, as x approaches infinity, my y value is also increasing to infinity. As x approaches negative infinity, y is approaching 0, and y is not going to go any lower than 0 here for the parent function. So this has a starting point at 0, 0. So my x-intercept is 0, 0, and my y-intercept is 0, 0. The transformation form, this time a is in front of the square root, h is under the square root, and k is after the square root. So let's talk about domain and range, since this one's a little bit different than we've seen before. My domain has a starting point this time. My domain is 0, and it's going to go forever to the right to positive infinity. So for the domain here, we're going to use a bracket on the 0, since we can take the square root of 0 and the answer is 0. So remember, domain is your x value. Range, your lowest y value is 0. So on the y, it's 0. So again, it's a bracket. And how high up is this graph? We see that it is increasing, increasing, increasing. And since we don't see a stopping point, this graph is going to continue increasing. So for the range, we go from 0 to infinity. And the last one we're going to discuss today is called the cubic root function. This time we're going to take the cube root of x. So this one does not grow quickly. It grows very, very slowly because I'm just taking the cube root. So for in behavior, as x approaches infinity, our y value also approaches infinity. Because even though the y value is going up slowly, it is increasing. That's my in behavior there. And on the left, as this graph goes to the left, as x approaches negative infinity, y is also approaching negative infinity as it goes down slowly. For the table, that should be an 8, we're going to take the cube root of the numbers. So the cube root of negative 8 is negative 2. The cube root of negative 1 is negative 1, etc. So it has rotational symmetry. Some of the attributes it has is that the x-intercept is at 0, 0, and that's also the y-intercept. So it's crossing your x-axis, and it's crossing your y-axis at 0, 0. In the transformation form, the a is going to come in front of it, the h is underneath the cube root, and the k is after the radical. The domain, how far to the left can it go? It's going to negative infinity. How far to the right can it go? It's going to positive infinity. Now the range, how low is the graph going to go? It is decreasing very slowly, but it is decreasing. So my range here, it's going to go down forever. So this graph right here is going down forever. It's going to be negative infinity to positive infinity because it is going up slowly. So hopefully this video helps show you some of the key attributes to parent functions. Stay tuned for part 2 when we discuss different parent functions and their attributes.